Hey guys, good afternoon, or in some state, good morning. I'm quite glad you guys can join us today. So I'm Sebatien Ng from Fronius. I have Trevor with me from Schletter and also Mary from Schletter. So if you guys can hear us, can you please raise your hand? No issues with the mic or anything like that? You can see us and everything? Yeah, people raising hands, so everything is okay. All right, everyone can hear us. That's really good. I can see people all over the country there. That's great. Really great to see all those names here. Definitely. So we will wait for a few minutes just to give a chance for everyone to attend from the start. So let's see how this goes. I will just give them maybe a few more minutes and then we can start the presentation. All right. So there's also a chat box if you guys want to type in anything just before we start. If you want to introduce yourself, maybe in the chat box, just a bit about yourself and the business that you're in. All right. We have quite a bit of a shy audience. All right, that's all right. We will definitely start. Okay, now I can see some question. Saying there's Matt here. Rob Farago also is here. Installing Brisbane since 2008. Wow, that's I think I was still in high school in 2008, if I'm not wrong. That's huge. I'm pretty sure there is a couple of you guys who've been in the industry for quite a long time. That's really impressive. Really impressive. We have Lee also, Onshore System Australia. Neil Garner is here. Klaus is having some issues. No sound. Okay, so let's have a look and see. I need to find you in all those attendees. So let's find you, Klaus. Okay, should be able to hear us. Maybe change some settings and try to dial back in. We have people from Queensland. We have Alan, who is a big fan of Fronius and IC, and looking forward to hear from Schletter. So that's huge. That's super good. Rob Manson, #1 installer in Tassie. Hi, Rod. All good. Now Klaus can hear us. That's good. Some legendary names that I can see here, but that's awesome. All right, guys, we have quite a big attendee and we have few topics to cover today. So hi again, my name is Sebatien, whoever came late. I'm an application engineer at Fronius. So basically we are trained with doing a bit of tech support, but also mainly with training people, looking at complex projects and also looking after customers. So today with me, I have Schletter. So I have Trevor and Mary. So Trevor will talk a bit about the company, And then Mary will talk a bit about their new platform, and Fronius will explain a bit with designing. So we still have common questions coming on our way, and yeah, definitely some of those topics we really want to cover with you guys. So we highly encourage that we keep the question at the end, so that we can get the flow going, and then from there, yeah, it should be quite straightforward. So I will leave it to Trevor from Schletter. Trevor?
Hey, thanks, Seb. Hopefully everyone can hear me clear enough. Good afternoon, everybody, and welcome to this Fronius Lunch and Learn webinar. Firstly, thanks to Fronius for setting this up, and to the sponsors, including Schletter, for some very generous items that they've sponsored for the attendees. Today, we are launching our new solar rooftop configuration tool, which is designed to assist installers and EPCs to configure their mounting structures in 20 minutes or less. Although the tool works for all rooftops, it's really targeted to the CNI, or the commercial and industrial market segment, for installations typically from sort of 10 to 20 kilowatts above. And this was in direct response to our clients who needed a more efficient way to design rooftop solar solutions themselves, versus working through our engineering team in Ingleburn to necessitate a much faster project turnaround time. So it really is it's a game changer in the industry at the moment. I'm sure you'll be very, very pleased with it. The tool will be available to download from our website. It runs on your computer and is updated real time through our servers. And the second part of the presentation is when I hand you over to Mari Magnon, our senior rooftop engineer, who will actually take you through the tool and design a simplistic rooftop to show you exactly how it all works. But before we get to that, I just wanted to talk a little bit about the company. I'll be very, very brief because I realize that time is of the essence here. So, okay, the rooftop market in Australia is an incredible place to be at the moment. We've 2019 installed over 287,000 rooftop installations, which is probably one of the biggest in the world right now, putting a total of 2.2 gigawatts in terms of commercial and residential rooftops. So this is by far the biggest segment of the Australian solar market, contributing to around 10.3 gigawatts of potential. The good news is, however, that according to the Institute of Sustainable Futures, the School of Photovoltaic and Renewable Energy Engineering, and the Australian Photovoltaic Institute, the potential in Australia is up to 179 gigawatts of rooftop solar alone, of which around 50% would be residential and the balance commercial and industrial rooftops. And this predominantly in New South Wales, Victoria and Queensland. So although we have unprecedented amount of rooftop solar installed, the potential for to increase this is phenomenal. The national average of solar system has increased up to 7.26 kilowatts from 7.1 kilowatts in 2018. So you're seeing a distinct rise in the size of these projects. The graphics at the bottom just show you the postcodes where the largest amounts of installations took place, led by Queensland and then WA down on the left-hand side there. And there you can see the installation year and the total amount of in terms of gigawatts of energy that was installed on the rooftops around Australia. So it's truly unprecedented. A little bit about the company. So Schletter is a global provider of solar mining structures. We've been in the business since 1968 and in Australia since 2011. Cumulatively, we installed around 35 gigawatts of mounting structures. In Australia, that figures around 600 megawatts. So It's a significant business because we're an international company. We have the ability to scale. Headquarters are based in Germany. We have production sites in Germany, USA, and China, and branch offices in all the major countries. So it truly is a global business. We don't offer simply rooftop solar. We also look at fixed tilt structures, which is a very big part of our portfolio. We've just launched a single axis tracking solution, which has already started to roll out in New South Wales. And then, of course, we do carport systems, and then various different rooftop systems. So we cover the whole gamut of solar mining structures. As I said before, ground mounted systems, flat roof, we cater for pitched roof as well, facade, carport structures. We've partnered there with a company called Solar Carport Solutions. And together with them, we will continue the rollout of our solar carports, and then more recently, the single axis tracking solution. So that's a very, very brief summary about Schletter and the market. And at this point, I would like to hand you over to Mari, our senior rooftop engineer, who will actually talk you through the configuration tool. Thank you.
All right, thanks, Trevor, for this introduction. So now we'll pass it to Mari. The audience is all yours.
Good afternoon, everyone. I am Mari Manhon, and I'll be discussing with you the short introduction of the tool and its limitations. So this will be the first page of the configuring tool, and then it's going to address only each roof side of the business. So it's either you have a flush mount or a slightly elevated system, which goes from 5 to 11.5. So a limitation of this that you cannot use this tool for elevation systems that you would intend higher than 11.5. And of course, ballasted system will not be included in this. There will be no facades, there will be no ground mounts, nor carports. And this tool, just to make it clear, it's a constantly being updated and improved. So I would consider this to be a work in progress regularly. So if you have any, let's say, questions, comments, suggestions, always feel free to raise them to us, and we will try to address them as much as we can. And you might find later on that you will see some German words still in the tool, and little by little we'll be translating those for you. So as an assumption for this discussion, let us use, let's say, for pitch roof, so you want just a flush mount, because this one, the elevating system might take a bit longer. And it's just an introduction. So we use flush mount, and then you go to project data. So don't worry first about the order number. We're still talking on how to serialize this one. And then the project name, you can go for ABC if you want. And then the company name, and then who is doing who's using the tool, and then all of this data. Now, for solar modules, I'd like to emphasize, I know there was a commitment of like under 20 minutes, and this is really going to happen after a certain number of times that you use the tool. Now, things that you have to prepare before using the tool, this will even maybe be lower than 15 minutes if you have the following prepared. So if you know the roof type, you know that there are several roof types. And just to give you some, roof types could be tiled, could be fiber cement, trapezoidal roof, sandwich, standing seams, bitumen or membrane, and then corrugated. So under each of those, you still have several types. And then under, let's say, a line-up trim deck, you have a vertical rail, so those types. So these are things that you have to be prepared for prior to the start. And then, of course, you have to know and identify the area where to mount with dimensions, and then an intended layout, what system you intend to use, and the module data. So for the module data, what we need is really the length, the width, the thickness or the height, and then the power that, let's say, so let's use examples here. let's say it's a 2 meter long, 1,000 wide, and then let's say this is 40 mil thick, and then we have 400 wattage per panel. And then clamping point, it is always best for you to have the manufacturer's data on the module. No? So there you will find the clamping points, and normally it's 25% from the edge. And then you'll get also the module weight. So if let's say this is 20 and you are not sure if it's 20 or 22, always take the lighter weight that you are thinking of. It will always be safer. It's more conservative. But of course, if you see and have the manufacturer's product sheet in front of you, you don't have to guess the module weight nor the clamping point and all of this. So once you have filled this up, you'll be allowed to move. You have a graphical representation here, and then you'll be allowed to open the location tab. Okay, location tab, of course, like I said, you have to prepare the info on the location. So let's say it's Sydney, just an example. And then let's say you have those points. And then let's say you have, of course, here you have to input the exact street, although that will not impact any part of this calculation. But this height above sea level, you have to know, right? So let's say if you're asking, oh, how will I know what's the height above sea level? And then how will I know what's the terrain category? Okay, so I suggest that you go and use the Google Earth, something like this. Let's say the project was in Derby. So just type there Derby and then go close. And then let's say it's this house, right, that you're doing a design on. So you try to measure that house from the sea. You see there, it's only 161. And then this, you have to know the level of salinity. If you don't, but you're facing already the ocean, you can be assured it's high in salinity. So if it's less than, let's say, 400 meters, the aluminum components will have to be anodized. But the thing that you have to know in terms of filling up the spreadsheet will be to know the height above sea level. So if we're doing a project on this roof, so the height above sea level, you will find here, this one here, the height. So if it's this one, you see it's almost 66. If you move around it, it's still 66. Okay, but this one is 61 on the ground. The ground will be 61. So this one most likely it's a 2-story plus 6. Okay, just to be safe. And then then you can fill up this one. Height above sea level was, let's say, 61. And then the terrain category, you see here, if you're not sure, please spend time in reading this one. At the start, you will not achieve maybe the 20 minutes because you're still acquainting yourself with the definitions of terrain 1, terrain 2, terrain 3, etc. So see coastal area. For that specific location that we use, definitely it's a terrain 1. Okay, that distance was terrain 1. So terrain 1 is sea, coastal area exposed to open sea. But if let's say your project site let's say was somewhere here. Yeah? So if it's here, and then you try to measure that place, it's 1 kilometer from here, and then almost 1 kilometer from there, then that will really change this one. It's no longer terrain 1. Most likely it's terrain 2. Okay, so terrain 2 area with low vegetation, such as etc., etc. So you know, and you'll have to acquaint yourself. So in the first run, try to read all the definitions so you'll be on the same page. And then if it's a house, 1, 2 stories, 3 stories, up to 15 stories, not many people will be in there. You can consider that as an importance level, which is 2, and then go for 200 years. But if you go for, let's say, higher buildings or their emergency facilities, their airports, hospitals, etc., they are high importance level, so you have to choose 500 years. Now, for the porosity, if you don't know, try to check and imagine the distance from it using, again, Google Earth. So if you're very near, this one cannot be moderate, maybe it's already severe. Okay, so almost equivalent of having swimming pools, chemical plants around it. Okay, so after you're finished with the location tab, you go to the building tab. Building tab, like I said, you have to prepare the dimensions of the area that you plan to install. So you have the gable to gable. So just to be sure, definition of gable to gable is that length. Ridge to eave is this. And then the height above ground, which we saw was 6 meters based on the Google Earth. And then roof pitch is, let's say it's 20, or you can go say 19 or 18, etc. And then the, let's say the common one, it's trapezoidal roof. And let's say you have timber purlins, right? So those types. And then now Rapid 16, it's the type of module clamp. So this is how it looks. If you want them anodized, because that area most likely will need to be anodized. So this is how it looks. And then here, don't mind this initially because we have not loaded the data that's intended for this configuration. But this one will tell you that these ones are going to be within the tolerance. Okay, then we go to configuration. Okay, configuration. So it was pre-filled already in previous page for the 20 and 10. One layer or double system. If you're not sure how it looks, you can press this down arrow, and then this is how it looks. If you chose the double layer, that's how it would look. No? And hold on, I have to go back to building afterwards. So now we do not need, let's say, to go cross-layer. We only need one layer. So we want to clamp on the long side, which is the usual clamping point specified by most module manufacturers. And then we want to, because let's say, assuming that it is a kingspan roof, we have a specially cut design drilled fastener for kingspan roof. So we're attaching only to the roof covering, meaning we are going to be fully dependent of the location of the purlins. So the mounting fastener that we plan to use is kingspan special design, which is Kingfish 2000 KT, which means a clip up. And so we have that, and then we know the thickness of the roof. And then when it's kingspan, the ridge to ridge distance of kingspan is 333, and the ridge top width for kingspan it's 30, and then the ridge height kingspan KS 1000 is 35, and then the valley of kingspan roof is 270. So you'll see what these T1, T2, T3 are. You'll see it from this. And based on the roof manufacturer's data sheet, you'll be able to get all of this info. And then now you will see that you have to decide now on the use of the rail. So the rail, you will see, let's say Echo, that's the cheaper one. Solo will be the usual, Solo Plus will be the stronger one, as evidenced by the amount of utilization that you'll see here. So this is, let's say, the end of the roof, which we want to plan out always, because sometimes the installation is not really limited to the center, so it's best always to plan based on the edge zone. So if you go for Echo, it's only 33, meaning you can use Echo Rail. And so down the line, definitely it's a lower utilization, but more expensive. So the goal is to use the Echo so that you have lesser investment. So no need for interior, you can use the connector E, and then the length here, it will show you what are available. So for the eco rail, it's only 4.3. Okay, so this area here, it shows you the utilization rate. If it's in the center zone, it's 70.2. Now, if you're in the end zone, it's 0. It's above 100, which is 101%, but it's in orange, no? So, but you see this one, the range to range distance of the Kingspan roof is 333. So this is 66.6. So you have to match it to 66.6 if you want to go 2 ridges. Okay. So you'll see it's allowing here, and then the orange one means it's okay to use this span, which is 2 ridges, 2 times 333. The fasteners per square meter comes out to be 1.6. Utilization of the module clamp 92.7. That is what you saw in this other tab, 92.7. I'll show you what happens if you, let's say you try to go and use 3 ridges. So 3 ridges will be like 1,000, right? So if you put there 1,000 or 100 cm, everything is in red. 105 and 151, especially on the edge. So that's telling you that going 3 ridges is going to be too much. So you go for 66.6, which is the equivalent of 2 ridges here. Okay, and then now we go for the layout. Layout, let's say the customer wanted to do 2 rows of 10. So you can edit that one to 10 per row and then 2 rows like that. So these lines here represents the range of the roof. So if you want to put it in the middle of the structure of the roof area, that's it. You're done. So you want to see the bill of materials. It's there. So you need 10 rails of the 4.3. You need 8 pieces of the connector, and then this is the fixed Kingfish 2000. We still have to improve. Like I said, it's a work in progress. And then it is 64 pieces of that. And then we have to add some self-tapping spools for this, which is 4 times 64. We have to manually enter that here. And then it tells you already the mounting clamp that you need. And then the ends, the mids, and then the grounding. Grounding, we normally allow 1 grounding clamp per row only. Okay, so these ones at the start, I will have to get what we call, let's say this one will be saved in an XML file that we call. And then I have to check it because there are still things here that have to be added. Because you see the configuration here, echo, you have to pick the anodized one, which are still not being done. So I have to check it because the location is high in coercivity, and we have to change everything to anodized. There are some limitations at the moment for this. We have another version in our office that I can use just to correct it. But at least you will have an idea of the expense. Don't mind these unit rates here. They are not true, they're just dummy figures. And you can immediately have an idea of the BOM. Okay, so that's the end of my present. I forgot to mention that you will only be able to get a copy of the design report if, let's say, it has been ordered. We are able to give only the BOM, but not the design report. So, Sebastian, maybe we can go and open the discussion to the questions and answers.
Yeah, thanks, Mary. So we will do this part at the end, but really great tool definitely here. Yeah. So maybe I will go with the Fronius side of things. But again, thanks guys for presenting on Schletter and a bit of history about the company. That was really, really good. So, okay, let me swap that here. Show my screens. Okay, go. So, all right. So can you guys see my screen? I'll just minimize this. All right. So we'll continue with that. So can everyone hear me clearly? Can you guys just show raise your hand on your side if everything is all right? Yeah. So a few hands up there. So it looks like, yeah, you guys can hear me. All right. So if you guys have any issues, just comment and I will rectify it on my side if required. All right. So hi again, guys. So my name is Sebatien Ng, application engineer at Fronius Australia. So today I will talk a bit about how to design with Fronius and in general how to general PV system. So on our side, sometimes we hear some information out there which is not 100% right. So we really want to cover the whole topic. So what we will have here, if I get the presentation, yeah, we'll use this. Is a pointer. All right. So what we really want to talk about today is the most popular residential inverter, which is basically our PRIMO range. You will see that the giveaway is actually a PRIMO inverter. So we will cover a bit about this particular one. So with our product in general, not only the PRIMO, but all our inverter, we always design it for the FRO concept. So what does the FRO means? The FRO stands for flexibility and future-proof. R is reliability of the product, and O is optimization. So today I will talk about the PRIMO 3 to 8.2 kilowatt and how do we have this FRO concept. So for example, with our snap inverter, especially the residential inverters, they all come with a data manager card inside. So why do we have a data manager card? Is to make sure that you can monitor the system there, but also to future-proof the system. So to know in the future, okay, do I need to add more PV? Do I need to basically do load consumption? Or also to integrate with other technologies. So this particular data manager card enables the inverter to talk to different components. And that's where the SunSpec Alliance comes into place, where we have a standard protocol in our inverter where we can talk to other devices. So it's basically, if you guys want to learn more about it, there's a lot of information online. Then reliability, you guys know that we have a lot of inverters out there. We test them to the limit. There's a lot of protocols that we go through. I always say to Australian customers how harsh of a condition you have here in Australia, especially in Queensland, in Western Australia, in Northern Territory. You know how let's say how much dirt you can have around the inverter. So we make sure that we test the inverter to the limit. And one particular thing that we are specialists in is basically to optimize the time that you spend with the inverter, if you need to install, but also if you need to exchange components. So we have a program called the Fronius Service Partner Program, where you're allowed to change boards. But if you need to swap an inverter, also it's really easy and simple. You have 4 screws and the inverter is off the wall. So we really want to make sure that in any inverter that we come up with is that it is designed with those 3 concepts to make your life easy on site. So let's have a look at the Fronius PRIMO. I'm pretty sure a lot of you guys know this range. So PRIMO, its prime means single phase. So this is our single phase inverter, and we have different sizes. So you have PRIMO 3 to 5, and the 5 here is basically the international version. Then you have the PRIMO AUS, which is a legacy inverter. Then the PRIMO SC, which is a 5 kilowatt inverter. And finally, you have the PRIMO 6 and 8.2 there. So one difference that you have with the PRIMO 5s, for example, is one of the PRIMO 5s, the maximum input current is 12 amps. Compared to the PRIMO AUS and PRIMO SC, it's rated at 18 amps. Then also you have difference in, let's say, the nominal AC output. So the one thing that we get a lot of question is, hey, what is your difference between all those PRIMO 5s? What can I do? What will the inverter how will the inverter perform? So there's quite a lot of questions. So we have summarized the whole topic in one table. So the first thing that you need to look is the PRIMO 5 International. So it is rated at 12 amps. AUS and SC, the maximum input current is rated at 18 amps. The maximum short circuit current of the 5 international is 18, the AUS and the SC is 27 amps. Now, this is the interesting part. People say, okay, because the inverter nominal power, for example, for the AUS is 4.6 kilowatt, that the inverter will produce maximum 4.6 kilowatt. It's not right. The maximum power of all the 3 inverters is always 5 kilowatt. So this is the maximum power. The nominal power is different. So the international is 5, the SC is 5, but the AUS is 4.6. What does this mean is when you oversize a system to claim the STCs, you need to do 33% times the nominal power. So for this particular one, you can claim only 6.11 kilowatt compared to 6.65 and 6.65 for the other one. So this is one of the major difference there. Then the second thing that people say, saying, okay, the max input current of the AUS is 18, the international is 12. So what happened there is people say, okay, this is the maximum input current, I can't go above that. The thing is, you can go above the maximum input current, but you can't go above this max short circuit current. So let's have a look and design one system so that you get a bit more information out there. So we have a configurator tool, which is basically checking the string just to make sure that it works. So from there, we just have a question. So I will cover the question at the end. So with the Fronius Solar configurator, is just to check that the system will work. There is a lot of configurator out there which does the whole thing. But for us, it's basically checking that, okay, on Fronius side, if you use those this software and if it tells you it works, it will work, and then it guarantees you in a way that your design is good. So I will show you the Fronius Solar configurator. This is how it looks like. You can click on login, and then from there it is quite straightforward. The first thing that I will show you guys is, you know, here for residential, you're capped at 600 volt maximum. So what you can do is on the Fronius Solar configurator, you can put a setting where it will only show you system which has maximum 600 volt. So for example, what you do is you log in. So yes, this is my full name. So you click on user setting, and then from there, you will see this page will show up. From there, you can set up the maximum DC voltage here to be 600 volt, press OK, and then from there, all the system will show up. So if you guys are doing RESI and commercial at the same time, so what I would recommend is please make sure that this is set up correctly. From there, you move to the next step. So you already know, you already set up the platform. What you do next is select the module. So really simple. For example, I selected REC there. I took an old panel, 250 watt. One thing that I do with all my design in Australia when installers call me to get more option, I change the module temperature from -10 to 10. We have a paper about this, a white paper explaining why do we change it. So I can go in more details there. I select whatever inverter I want. So here it is a PRIMO 5 International, and I say, okay, I want to oversize it by 140%. So the inverter, actually, you can do 150. I just wanted to see all options that I could there. So from there, I click next, and then from there I scroll down and I see all the options. So at the top you can see the maximum DC power connected to the inverter, how many panels you have connected to the inverter, and it gives you all the string configuration. So here, looking at the option, the one that I wanted to select was 2 times 8 on the first tracker and 1 times 11 on the second tracker. Now remember that each tracker, the maximum input current was 12 amps. The maximum short circuit current was 18 amps. So just to show you, when I click on this option, what I would see is this particular table here on the right hand side. And it tells me that, okay, your max short circuit current at 25 degrees is 17.72 amps. I'm not going above the short circuit current, I'm still below it. And then you can see per string, it's 8.28 amps. So what will happen is we're gonna add those two current on the first tracker. So remember, inverter is rated at 12 amps. So let's see what will happen to this PRIMO 5 International. In my design, what I selected is to do an east and west with those 8 panels. And then, so I will just go back for a minute. So here, the 2 times 8 goes from east and west, and the 1 times 11 is facing north. So the one that I want you guys to focus is this 1 times 11. So, sorry, the 2 times 8 there. So let's have a look at that. So if you have 2 strings of 8, so one facing east, the other one facing north, early in the morning, we can say that, okay, the first string, you will have 10 amps, and then the second string, you have 2 amps. It comes to the inverter, you add that together, and you have 12 amps. You're not going above the max input current. During let's say in the middle of the day, you can have 7 amps going into each, the first input, which makes 14 amps. Now, there is 14 amps available, but the inverter can take only 12 amps. So what will happen is, if you think about this scenario, the panels are basically the source of energy, the inverter is the load. So we will just take 12 amps. So you have a bit of losses in this situation. Then in the afternoon, it's basically what happened in the morning, but on the opposite tracker, for example. So then we need to understand what happened to the actual system and where do you have a difference. So if you look at parallel 2 string on one tracker, so let's say in the morning, for example, you have 2 amps, 10 amps, the currents get added and it goes 12 amps. You're not going above the limit. Then from there, if you have a 2 tracker inverter, then the current will go to one tracker, the second current will go to the second tracker. And how do you do the calculation of how much power? It's basically this formula there. So you take the voltage here, so the total voltage in series is V1 plus V2. So this one, if you need to calculate the power, will be 2 amps times the voltage plus 10 amps times the voltage. This one is different. You need to add the current, and then you need to use this formula. And that's where you have a bit of losses. Now, the question is, how much losses do you have in those type of situation? So let's take this scenario, for example. Again, let's say it is an east-west situation. It's early in the morning. This string has, let's say, 5 amps. This string has 1 amp. It goes to one tracker. The current will be added, so you don't have any losses because of current. Even if you have 1 or 2 trackers, it will be the same amount of current coming to the inverter. What will be different will be the voltage. So for example, at 200 watt per square meter, you have, let's say, 33 volt. And when you have 1000 watt per square meter, you have around 34 volt. This is where you get a bit of losses, where the voltage is a bit different. So the first place that you can get a bit of losses will be when you're paralleling and you go above the maximum input current, if it happens, but usually in east-west, you can see most of the time you will be below it. Then the second time that you can have a bit of losses is when the voltage is a bit different, but you don't have losses because of current, let's say in the morning, except if you go above it. So that's one important factor to consider when it comes to designing east-west on one tracker. So people think that having basically 2 trackers versus 1 tracker is always the best. So we have a white paper which explains that clearly, but it's not the case. So it basically produces quite the same amount of power. So we had basically 2 single tracker inverters. So each has 1 string. And then we have 1 single tracker inverter with 2 strings parallel to it. And it's the same case scenario. And here you can see that the system produced the same amount of power. So just to show you, this was a case study that we did, but we also have a system here in Australia. We have few systems here. People are starting to do it more, especially with our commercial inverter, which is single tracker inverter. What they did here is they parallel 3 strings and 2 strings. So 3 strings facing west and 2 strings facing east. So if you look at the system here, so you can see that 3 strings facing west, 2 facing east. The most interesting part is they had a bit of shading here also on the panel. So what we did is we wanted to compare what the system produced, because we have 5 inverters on site, and some of those inverters has all the panels facing one direction, for example. And it was really interesting because on our solar portal, when we measured all the power, it was practically the same. I was quite surprised by it, because also there was a bit of shading on some of the panels there. But you can see that we have data to show that you can do an east-west or split system on one tracker. So the next part is basically with our Fronius smart meter. So we always say to add a smart meter on a system. Why to do so is to future-proof the system. Because if you have a smart meter installed, you can define load. And also, if you look at, for example, Facebook or any other big company, you can see that data has always value. And we highly encourage installers to add that, because in the future you will be able to do simulation, and there will be a whole package if you have a smart meter, because we need the data to be able to see what's happening on the site, so that we can give recommendation for example. So from there, it's quite simple. How do you install a Fronius smart meter? So it sits usually after the main switch of the property. Then you have the Modbus communication to the inverter, just RS485. There's also Wi-Fi option, but I won't cover that here. One thing that we see quite often is with a twisted pair, this RS485. When we say twisted pair, it's really interesting. I learned it the hard way, I would say. So when people say twisted pair, they have, for example, blue and white and blue. They twist it together and then they put it in D positive. Then they take another pair, green and let's say white and green. They twist it together and put it into D negative. When we say twisted pair, you need to twist, for example, blue and white together. One end goes to D positive, the other one goes to D negative. So that's how you do twisted pair. Then you bring your earth cable there. So that's really important. It makes a difference, definitely. So I highly recommend that you have a chat. I always ask installers, hey guys, how do you do this? And it's always interesting answer, but highly recommend to do twisted pair like that for the RS485 cable. Then the next step is setting up the meter. So it's always kind of on our side. I think there's some confusion when it comes for installer to put the inverter and enable the inverter at the right location. So the meter, as mentioned, needs to be set up after the utility meter. And from there, this is what we call feed-in point. And how do we do the calculation to see how much is going to the grid? It's really simple. So we have a data manager card. We know how much the system is producing. And then from there, we know how much the meter is seeing power going to the grid. So we just take whatever the inverter is measuring, whatever is going out, this is going to be our load. So when you activate the meter, you need to select feed-in point. The thing is, some people think that, okay, I'm measuring consumption on site. That's why I have this meter. So I will activate it as consumption point. But consumption path here is basically this setup. So one side you have the utility meter and the inverter, the other side you have all the loads. So that's what we call consumption path. In general, I would say just remember this option, feed-in point. That's the way to go. That's how you do export limit, for example. So that's pretty much it on my side. 24 hours of sun. This is basically our vision, 100% renewable. I think what we'll do now is take a few questions, because I think we got a few coming through. So maybe I will get Mary to join me here. Okay.
Yes.
Mary, you still here? Yeah.
Yep.
All right. So let's now answer a few questions. I think at the start we had few for you. So all right. Okay. The first question was, where can they download the configurator?
This configuration tool will be available in what we call the Open Solar outlet Solar Juice and our website. So it's not yet available now, but it will soon be very easy to use once we have configured everything and then linked to Germany. Because once it's downloaded, you have to only realize that there's no way of updating that tool. It's always best that you don't download and then you keep on using that. It has to be linked to Germany and then you download every time you use it so that you always get the latest version.
Okay, so do you guys have like a guide to help some of the guys so that we can send them what would be the process later on? Yeah.
Yes, we're still preparing all the documents to make it easy to use it.
All right.
And how to download it, etc., where it will be available. So that's still being prepared at the moment.
Mm-hmm.
So Sebastian, it's Trevor here. If I can just comment as well on that one, the tool will be available via the Open Solar platform. We've partnered with Open Solar to configure entire systems, including now the Schletter racking system. So when you go down to, once you've configured the modules and the inverters and you go down to the balancer system configurator in the Open Solar platform, you will see the Schletter logo there, which will then redirect you to the tool, which will be initially hosted at our website, and then it'll be hosted as well on Solar Outlet, www.solaroutlet.com.au, and also on the Solar Juice website.
Yeah. The next question was, what is the image resolution? Like there's a location, Pine, Queensland 4800. The concern is that Sydney may be a representative example. So yeah, what would, let's say, what would be the resolution for Queensland?
I didn't quite get the question. When you say the resolution, what does it mean exactly? I mean, resolution of a picture, or what is it specifically?
Let's see if Alan asked. Okay, maybe if Alan, you can clarify this one. Let's maybe move to the next question, and then come back to this one. Someone has downloaded the software, but it is in German, and is there a way to change it to English? So yeah, so someone got their hand on the software. Is it do you guys know about it?
So let me, that's not the latest software, that's the German version. The refined Australian version will be uploaded by the end of the week, and it will be labeled in English, so you will see. It's also the tool that we've spoken about is specifically configured for the Australian market using the Australian spanning tables and certification. So any project in Australia that is designed on the tool will be pre-certified, and it will issue both a bill of materials, and then once you place the order, you will get a full 20-page design report, which will give you all the engineering technical details that's required to install this. So just wait till the end of the week, guys, and the Australian version will be uploaded.
That's awesome. There's another question. Yep.
Just in case, I am not sure if what version the gentleman was using, but on the first tab, you'll see some things on the top that says file, language, tools, options, etc. You can try to go to language.
Okay.
And then there's German, English, American English, French, Spanish. So, but our tool will definitely be having English as one alternative. But I think even the one that he has right now, he can go to the first tab and use click on language in the top.
Yeah. Yeah, thanks for that. The other question was, do we have time to review a solar car park solution? So I think that's one thing that maybe you guys can take on board on Schletter side. Maybe we can do another webinar when we can show a car park solution, for example, but just running a bit out of time. Maybe now a question for Fronius. Okay, so are Fronius bringing in the PRIMO 5 AUS and none of the wholesaler have any? So yes, we are bringing some, but you will need to buy it directly from us. So I will make note here to make sure that we contact you guys. We're gonna include that in the mail out about the PRIMO 5. So basically, the PRIMO 5s are, especially the AUS version, is used for like replacement, especially in Queensland. And yeah, so that's where we're keeping the inverters for. So Mike, if you just get in touch with us, and we can provide more information of how to get that. Okay, my favorite question of the day: when will the PRIMO and Simogen 24 Plus be available in Australia? So there is some changes of plan on Fronius side. So we were planning to bring the PRIMO, then the Simo. So PRIMO is the single phase, Simo is the three phase. There's some changes. We're bringing the Simo first and then the PRIMO. So the Simo, we have an ETA of Q3, Q4. As you may know, there's some challenges with getting let's say, product via sea freight or air freight even. We have a lot of containers which was already on the water, so we're not too concerned about that, but because it is a new product, we need to see how all the traveling things will go on with Europe. If everything is clear, Q3 should be there. Definitely we're going to have a training of how to install it, how to commission it. So in the next few months, we're going to bring a lot of training for the Simo, which will be similar to the PRIMO, and you guys will be trained to basically do all those activities. So 100% follow us on Facebook, Instagram. There will be a lot coming your way. Then next one. So I have, okay, there is some feedback for our solar configurator. They want to be able to use more panels. Okay, yep, definitely, Alan will take that on board. So you want to have more options with our designing tool, not only select one and then look what is available. You want to select few, so definitely we'll take that on board. What is the max AC short circuit current capacity at the output of the inverter? So the max AC short circuit current will depend on the inverter itself. We'll need to go and look at which inverter you're referring to, but on the data sheet you will see that what's the maximum AC output of the inverter. Does the inverter has active islanding? So we have passive islanding. So yeah, that's quite straightforward. So is east and west configuration specific to the eco only, or can we do east west on MPPT A and Fronius or PRIMO? So east and west can be done within any, let's say, any inverters. The eco, especially, what we have with that is you sit at a perfect voltage. Because when you have a three phase coming, let's say you have DC three phase coming in, usually you need around 680 volt, so that you don't need to, let's say, boost or play with the voltage, so that you have your perfect 415 volt on the AC side. So closer you're at, closer you are to the 680 volt DC for three phase, the best it will be. So east and west configuration, it applies for any inverters. Of course, with this east and west, for example, the international that I showed you, this is where you can make an international work. If you have an east and west, it's perfect. But if you want more flexibility, then you can go with the PRIMO SC, which has a higher input current. Really like to look at performance of string on a 3x27 eco side done to optimize. Okay, so there is some options question. So there is some question with commercial, so I will go back to that. So Schletter, there's a question for Schletter in regards. No, wait, it's not okay yet. Does Schletter provide a generic engineering certificate for various system and potential Australian location?
Our certification, our general certification comes from the German structural office, and this is certifying all the inputs coming from our tool. So deviations from that will not form part of the certification. Only if the tool, together with the design report, of course, you only get design report upon order, will be the process that we call certified. But it is a German structural office that certified it. We have an Australian certification. Again, if it follows that thing that we're saying, the contents of the design report and all the components that are Schletter, and if they follow the mounting instructions.
Yeah, sweet. All right, the next one, in regards to Selectronics certified inverter, what is the main difference between these and not certified? So basically, we give the inverter back to Selectronics, and they make things easier for you on site. So there is some few things that they do to the inverter. I can't go in the specific. We are doing a training on Thursday with Selectronics. I think it would be a good question for them to answer, but it's really something on their side. But not too much difference, but all Selectronics inverter goes to them for sure, and they need to be aware about what you have installed there. So yeah, few difference, I would say. I won't go specific there. There's another question. It's saying that Mary, just to go back to the first question that we have about the resolution of the image. It's saying that most design tools use near-maps image, but last near-maps overflight was only of the Cyclone Debbie, and that was only ALI Beach. None of the regional towns within 100 kilometers have near-maps image that's worth a P. Yeah, I won't comment. But he's saying that it's not worth. So how is the quality of the image on the software?
The software only utilizes Google Earth, so we're very much dependent on the resolution of Google Earth. And actually,
so it's
near-maps actually being used by designers, wherein they want to see even the finest obstructions on the roof when they come out in making layouts. But let's say our Google Earth, the two most important things we only get from Google Earth is actually height above sea level and the terrain category. So resolution is not really too much of an issue. The high resolution is really needed when you're doing actual layout based on obstructions on the roof.
Okay, yeah. I think that was clear on your side. So doesn't look so there are just some recommendation from Brian saying that you can use Queensland Globe, has more update images. I never heard about this, but yeah, something maybe fun on your side, some feedback. All right.
Yeah, there's no problem really with all of those tools that would identify the terrain category and the height above sea level.
Yeah. Let's see if we have more. Okay, looks like we had quite a good question Q&A time. So one thing before you guys go, thanks for attending the first of this webinar series. Please don't forget to register for the second one. That's basically you need to be registered for all the series to be qualified to win the system. So the first one is this one, then the second one is RESI, and the third one is just coming on our Facebook page. But we have all the links and everything. We're just gonna do a quick live video where we're gonna choose the winner. But highly recommend to come and attend the other one. The other thing that I wanted to share with you guys is okay, there's some question, where is the registration link for the second webinar? So I will ask the team to send you the link also to the second one. Just gonna write it down, link to the second one. So make sure that you have that, but it should be also on our Facebook page. Yeah, it should be quite everywhere. So check this out. So highly recommend to go and register for the other one. But also what's happening this week. So we have a webinar this Thursday with Selectronics, as mentioned, but this is where we're going to talk about the new solution with a three-phase inverter. So we've been waiting for this option for quite a long time. So you can register. Again, all the links will be on our Facebook page. You should also receive a newsletter if you have registered for that. But also on Friday, we are doing the first commercial webinar series. So this first one, it's open to end customers. So if you have any commercial customers who are end customers who are just on this fence, they're not sure, hey, should I basically go with solar or not? And we know that commercial has slowed down a bit. So please ask them to join. So we have an accounting department or an accounting firm which will talk about some of the solution with some instant asset write-off, so that they can claim from the government. And Fronius will also show you how easy it is to install commercial. So we've heard it so many times saying, hey, it's too complex, but I can tell you the small RESI especially, it's basically as if doing residential. So if you're scared of doing commercial, you think that it is hard, please come at least to the first one. You can get a good gauge of what we have to offer. Again, same time, 12 p.m. But yeah, after that we can show you how to save. Just to give you a ballpark, we had installers who basically save nearly $10,000 to $20,000 on commercial, and they didn't realize how easy it was to design, especially with Fronius. So some unique features that we're going to talk there. So highly recommend you guys to check our Facebook. There's a lot of things happening this and the next week. So looking forward to see you guys there. There's one question again for us, which is, will Fronius be offering a two-phase 460-volt option? At the moment, it's not on the table. We are focusing on our hybrid inverter and new commercial inverter, but yeah, not there yet. All right. Any other questions, guys? No. Looks like it's all good. All right, thanks again, guys. Thanks everyone. Thanks for Schletter, also for participating with Fronius here, and we'll see you guys for RESI. Don't miss this chance to win the whole system. Definitely looking forward to catch up. So glad that you guys came to our training. Thank you, guys.